Hello, my name is Mark Pachaboski. I work for RAN 3D and Ascent, and today I'm going to take a look at explaining how the position sketch and sliding sketch works in CATIA V5. This is something that, while many people are used to using a sketch in CATIA V5, they may not fully understand what is going on with the differences between a position and sliding sketch. So, what we have here is a simple brand new part. We've got the three default datum planes, and in the upper right hand corner we have the regular sketch, or referred to as a standard sketch, or sometimes referred to as a sliding sketch. All that means is the system's going to default a lot of the values for you. And we also have, if you hit the drop down arrow, what's called a position sketch. The position sketch looks like it has a dialog box in front of it. Now, the difference between the two is one defaults all the settings and the other one gives you control of those same settings. Now, a lot of times standard sketch works just fine. If I click on it, I still have to tell it what plane to be built off of. So I'll choose, this case, the YZ plane, and it puts the vertical and horizontal axis in a specific orientation on top of the origin of the part. Now, if I turn the part a little bit, we can see that the three default datum planes are there, and where they all intersect, that's 0, 0, 0 in the X, the Y, and the Z, and that's where the vertical and horizontal axis go. A lot of times when you're building a part, that's all you really want and all you really care about. You can always hit the view normal or normal view command to be able to lay it flat again, and you can draw whatever shape you want. So let's say I wanted to build, let's go with a hexagon, and I wanted it to be a certain distance away from the origin. So I could get an offset between the vertical axis, and I make that 50. And I'm going to make the distance from the center point to the horizontal 60. Now, even though your vertical and horizontal axis went to a specific location, we can use them as references to help build our geometry and build our sketch. So we would constrain everything else here. I'm simply going to put a value here. We'll round it off to 25. And to keep it from rotating the whole thing, I'll make that horizontal. So everything's fully constrained. If I exit this sketch and build something out of that sketch, let's make a little wedge here, some little block. If I go to build my second sketch, if I use the same regular standard sketch, select on that flat surface or even this datum plane, the origin is going to go back to wherever the system defaults it to, which it puts it back here. I want to be able to put a hole in the center of this part. Well, the problem is I need to find where that hole is. Now, I could do the offset distances and be able to get it there, but I don't want to have to reference that. I want my sketch to be able to be put so that the vertical and horizontal axis is in that position instead. So I'm going to exit the sketch, which actually gets rid of the sketch. The sketch doesn't exist anymore. And I'm going to build a brand new one, but this time we'll go with a position sketch. With a position sketch, if you only select a datum plane, there is absolutely no difference between the standard sketch and the sliding sketch, or the standard sketch and the position sketch, excuse me. The only way there's a difference is if you fill in these fields. Now, if we accept the implicit, which basically means default, the default is part origin, which is the same as choosing part origin right here. However, I could choose projection point. With a projection point, I can pick a point in space, and it projects the origin onto the sketch plane, but aligned with that point, whatever I chose. So if I turn this so I'm looking at it normal to that surface, it'll lay flat, and we see it's directly on that point. Okay. Turn this so that we can see it from perspective again. If I said intersection of two lines, I'll be able to choose two lines. Maybe this line and that one, and where they either intersect or where they would intersect if they did cross one another, but would eventually. So for example, if I change line 2 to be this one, the intersection point is the corner where if this was extended out and that was extended out, that's the point. Actually, the point would be out here, and it projects it onto the sketch plane. And there's midpoint. If I choose the midpoint of a line. If I choose a line, it finds the midpoint and then projects it onto the sketch plane. And if I said bury center, I can click on this surface and it automatically locates the center of the surface area. Again, if I tell this to lay flat, so we can see it straight on, we see it's in the center of the surface area. Now, the orientation is how it turns into the position that we want. Right now we have it set to implicit, which means it defaults for us. But I could say, no, I want, in this case, the horizontal axis to be aligned with the x-axis. Now, if it can't do it, it'll give you a warning message. If it can, it'll spin it into that position. So here it's lined up where the horizontal is basically parallel to the y-axis. Well, you can see the y-axis right there, and this is parallel to it. Didn't really move much. Or I could say, no, make it with the z-axis. And now horizontal is pointing parallel to that z-axis. You could also make it through a point, so it passes through a specific point. Maybe I choose that point right there. It turns it at an angle, so the horizontal is going through it. Or I can say parallel through a line, and it's going to go parallel to this line right here. So horizontal is parallel to that. It gives us the orientation. Basically, how is that aligning with the model in the background? Now, once we define it, I'm going to go back to through a point, and I'm going to pick on this corner right here. What that means is when I hit OK, vertical is going to point straight up, and horizontal is going to point straight to the right. And this model is going to twist and turn to line up with that sketch. The idea is that you're giving control as how the part is viewable while you're working on the sketch. You could also reverse the H. So now what it would actually do is it's going to spin 180 degrees, flip over like that, and show it to us like this, where vertical is up and horizontal to the right. Or I could reverse the V, or I could swap both their positions. Now to illustrate that, when I hit OK, watch what happens to the V. It's right now going to the right. It flips it over, rearranges the entire model so that vertical is pointing up and horizontal is pointing to the right. Now, there's a lot of times you probably don't care the orientation of the vertical and horizontal. If I was drawing a circle, it really wouldn't make a difference to me. But if I'm trying to draw, let's say, some other unique vertical and horizontal shape, like an L shape or even an M shape or some other kind of defined shape where there's a top and a bottom and a left and a right, we may want to control where the vertical and horizontal is so that we can reference that to align it the way that we need to. A circle just doesn't have the alignment that a defined shape would. So I now can draw, in this case, it wasn't that critical, the vertical and horizontal, but it was critical where the center point was. So I'm able to draw this shape, in this case, a circle. You could do this the whole command and create it a little simpler, but I'll come in here and draw this as a 20 millimeter diameter. And since I don't want to build this as a whole, let's go ahead and build a solid block out of it. We will pad that out to some distance. Now, again, a position sketch and a standard sketch are exactly the same. The only difference is whether you care about where the origin is going to go and where the vertical and horizontal arrows are going to point. If you care, you should use positioned. If you accidentally build one in the wrong state, or you realize after the fact, I should go change that, you can always right-click on the sketch, go to whatever the name of that sketch is, object, and say change sketch support. You do have to be in the part design workbench for that to work. It refers to it as a sliding sketch because it was a standard sketch to begin with. But I can come in here and I can say, no, that should be a position sketch. I'm not going to let it move the geometry. So the geometry is going to stay where it was, which we have rules or constraints holding it there anyway. And now I could redefine where that origin is. Now there's not much to work off of because there's only the 3 default datum planes. So that's why with a rig, just the first sketch, a lot of times a standard sketch is just fine. But if I had something to work with, I could choose a part, or I could choose a projection point or an intersection of 2 lines that exist. Or I could change the plane it was on. Maybe I don't want it on the YZ plane, I want it on the ZX plane or some other plane. But that's how you're able to basically convert a standard sketch, or what we call a sliding sketch, into a position sketch. Okay. Hope that gives you some ideas when working with the sketch command.